There we go. We are live. So it is November 13th, 2014, 11 a.m. This is DB Hangouts. Today we're going to be talking about some more uses of Orchestrator by its creator, Shlomi. And then we're going to move on to dealing with logical corruptions and some more information around that. And if we have time, maybe even talking about mixing data and metadata. So let's do a quick round of introductions first. My name's Jeff. I'm a DBA at Box. And let's go ahead and jump to Tim. Go for it.
Hi, I'm Tim Callahan from Tokutech.
Okay. Shlomi?
Hi, I'm Shlomi. I'm just leaving Outbrain and joining Booking.com at the Netherlands.
Okay. Him?
Hi, my name is Pim Vanderwall. I'm DBA at Acquia.
Cool. Morgan?
Morgan Tucker, MySQL Community Manager at Oracle.
Okay. John?
I'm John Cesare. I'm a DBA at Square.
And Jeremy?
Jeremy Finley, DBA at Etsy.
And Jean-Francois?
Hi, I'm Jean-François Gagné. I'm from Booking.com. I'm a system engineer.
Okay. So, yeah, without further ado, Shlomi, since you're tight on time, go ahead and take it away and do your thing.
Cool. So I'm going to do the screen share, and let's see that it works. You should be looking at an Orchestrator screen right now. Okay. And we have a simple single master, 3 slaves topology, and we're already familiar with dragging and dropping slaves on top of one another so as to modify the topology. And what I want to show today is a thing called pseudo GDID, which allows you to refactor your topology even in the event of a corruption of one of the servers. So right here in the background, I'm stopping one of the nodes, and within like 10 or 15 seconds, we should start seeing evil stuff going on. So the black one over here is the node I just killed, and its 2 slaves are now red, means they can't replicate. Okay, they're lost. The replication is stopped. They don't know what to do. The server is gone. And typically, we're accustomed to assuming these 2 are lost because there's no way to connect them with the master, with the original master. Now, GDID in MySQL 5.6 comes to solve this problem, right? You say there's a global transaction ID running on everything, and this slave can check the last global transaction ID that it's executed, and then go find out that global transaction ID on the master and just repoint itself onto the master at the right position. And whether you're using MySQL 5.5 where you don't have GDID, or you're unable to migrate into GDID, one of the problems with GDID in 5.6 is that it's an all or nothing. You have to bring down your entire replication cluster and reconfigure it with GDID and then start it up again. You can't just migrate it slowly, one slave at a time. So for these reasons, I thought it would be nice to have a different solution. This was inspired by Sam Lambert from GitHub. And I'm going to show how I'm using pseudo GDID to move that slave onto that master, even though there's an intermediate dead machine. And hopefully the screen is going to refresh right now. Yeah, it made it. So there's actually queries running right now against the master. So in the event of a wrong assignment, these slaves should break down with duplicate key errors or stuff like that, but they don't. So I'm able to recover an intermediate master failure and promote slaves from beneath it, and I just go and bypass the problem. So that's what pseudo GDID is about. Likewise, I can bring down the master, and even though all of the slaves might turn up, with broken replication at different positions, different locations. Maybe some of the slaves were able to grab some relay logs from the master, others weren't. I'm still able to synchronize them all and choose the one that I'm going to promote to be a master and just combine everyone just in the very same way I did. I did that visually over here, but it's all API and backend, so you don't need GUI to do that. You can have automation to do that. And with your permission, I would like to explain how sudo GDAD works. So let me share a document here. Okay, cool. Can you all see the screen?
Yep, looks good.
Okay, good. Okay, so quick recap. We have a MySQL server. It writes binary logs. The binary logs are, just files. They may terminate. They may be of different length, depending on flush commands, server restarts, whatever. So the binary logs are not necessarily consistent in length. A slave copies those binary logs onto its own local relay logs, but we know that the size and numbers of relay logs are not necessarily matching that of the original binary logs, right? So I could have a longer relay log here, smaller one here, maybe I did flush logs. There's all sorts of reasons why these files would be of different number, of different size, and hence different binary log file and positions when I replay statements. If that slave is also using log slave updates, then once it replicated statements, it logs them yet again into its very own binary logs, and again in completely different numbering system, right? This could be log bin 0005, this would be 17. Again, breaking the files at different positions, not necessarily at the same length, etc. So how is it possible to, these binary logs are different from the relay logs, which are then again different from those binary logs. How is it possible to synchronize two servers that have been separated by some mishap, like an intermediate master that failed, or just whatever corruption, they lost position with one another? How is it possible to make that magic? So there's one method of doing this which is used to some extent by MAJ, which backs up the relay logs. So there's a daemon that copies the relay logs and backs them up before they get purged. That's a nasty thing with relay logs. It's nasty in terms of me trying to make that work, right? They get being purged as the slave gets along replicating the data. Once it replicated all the statements from some relay log, that relay log is not in use anymore, and it's auto-deleted. And it's difficult to rely on the fact that the relay log is going to exist when you need it. They get purged at any given time. However, the binary logs produced by the slave, again, assuming it's using log slave updates, are always there. You can set your own expire log days, or it's much more reliable to assume that the binary logs are still there. So I'm going to throw away the relay logs in this discussion and only relate to the binary logs. Sudo GDAD is a concept where you inject a unique statement periodically, like once a second or once 10 seconds. That statement could be like an insert into some table value UUID, right? Anything that's unique. It doesn't have to be ascending. It doesn't have to make any sense. Just something that is unique and is identifiable in the binary logs. When you're using statement-based replication, it's easy to do. When you're using row-based replication, it's a bit more tricky because most insert, update, delete statements just turn out to be garbage in the binary log. So you can use like queries like create or replace view as select unique value from dual, stuff like that. So it's pretty easy to inject statements which are unique. For the purpose of this slideshow, I've identified them by 4 different colors. And these statements are interleaved with your normal application statements getting replicated onto the relay logs, different files, different positions, getting executed by the slave, being written again into the slave's binary logs, again, different files, different positions, but under the same order. And more than them being written at the same order, it's nice to think about the concatenation of the binary log as like one virtual binary log over here and one virtual binary log over here. I don't know about the parts, the numbers, the files, but if I look at the entire sequence of the binary logs, then it's pretty much the same, right? Just that one is lagging behind the other, right? The master might be like 10 steps ahead, like 10 statements ahead of the slave, but it's pretty much the same. So the next step is to, let's say there was an intermediate master or whatever, and I need to resync this slave with this master. The idea is to find the last identifiable pseudo GID statement on the slave, and then go and it's a unique number, right? Say there's a 1, 2, 3, 4, 5, something that I can identify as a perfectly unique value. I go and search that value in the original master's binary logs, right? And that makes for a synchronization point, a very easily identifiable synchronization point. And once I have that statement here and that statement here, I know that anything before those statements is already up to date, is already in sync. Now, what happens after that, the pseudo GDAB statement in the slave's binary log? There's still a few, like maybe 10, 20, 2,000, whatever, normal statements issued by the replication, which made it through just after the binary, the pseudo GDAD statement. What I'm going to do now is start at this position on the slave and at this position on the master and start reading the entries of the binary logs as of that position. And these should match perfectly to one another, right? So there's an insert here, there should be a matching insert here. There's a delete here, there should be the same delete over here. There are a few bogus entries like end of binary log file, stuff like that. We can safely ignore them, but otherwise we expect the exact same sequence. And we're looking at the exact same sequence until we find out that we've reached the end of binary logs on the slave, whereas there's still a section of statements on the master that are unknown to the slave because it broke down. At that point, I take the slave and point it back to that position where we ended the comparison of all identical statements and reached, okay, thus far we know the slave has been through, and starting with this position, all statements on the master have not been delivered, executed, whatever. I don't really care whether those statements were in the relay log or not. I just care about whether the slave has executed them. I don't even care about corruption of the relay logs. The slave might have shut down and the relay logs were corrupted. I don't care. I'm just relay logs that it's produced. And thus I'm able to pretty much safely, you may need to use sync bin log or other variables, but it's safe to now connect the slave back to the master at a known position and just make the magic work again. So this is how it works.
Question.
Yeah.
Sorry.
Sure.
Yeah. So with that unique synchronization point that you kind of find, and then
Right.
you walk to see matching statements. What happens if you
Right.
find a mismatched statement, but then a matched one again? Like, do you kind of scan through a bunch and see that there's mostly a chunk of correctness, or
no, I expect identical sequence of statements. There shouldn't be, like, maybe your application may connect to the slaves and issue an analyze table or something like that. Okay, that needs to be integrated into into the code, right? We might ask the code to skip certain statements, but otherwise I'm actually expecting the identical set of statements, assuming you never issue statements directly on the slave.
Gotcha. Okay, that's good to know, specifically the analyze table stuff.
Yeah. Okay. So it's pretty easy to promote a slave onto its master or onto any of its ancestors, because it's clear that it has to be to some extent behind them. And it's also very easy to compare siblings of the same master, whereas the master has failed. It's pretty easy to know which of the siblings has replicated the most, and just point all of its siblings and enslave them beneath it. It's a little bit trickier when you look at cousins, but then it turns out that it's pretty easy if you just try it both ways. One way will end up saying, hey, the slave has actually more statements than that slave. And when you go the other way around, you say, oh, okay, then I have that point. I can see where I was cut off and the other slave went ahead, and you can do the magic. And so I suggest that pseudo GDID as a competitive feature to real GDID, where GDID is unavailable, and you can actually do the magic. I mean, that's the that's what GDID is all about. You know, being able to connect slaves to one another without all the hassle of the binary log files and positions. So I built this into Orchestrator. Orchestrator is smart enough to do the binary log files and positions math, and you don't need to know anything else beyond that. You just need to do the injection of pseudo GID statements, which I offer at the Orchestrator website. You know, here's a statement you might want to issue, and otherwise it's non-intrusive. Other than injecting a SMS statement once a few seconds, it's non-intrusive. You don't need to change your setup. You do need log slave updates. You might want sync ping log, but that's pretty much it. Yeah, I made it in 15 minutes. Yay! I'm happy if there's any questions.
Nobody? No one has questions?
That's pretty. I mean, pseudo GTID is really, really cool. I'm kind of trying to grok the either. It shouldn't be like any performance impact, right? Like, because I mean, you're just kind of scanning what's already there to try and match, like checksum for checksum. And so that was, I think when I originally saw it, I thought I saw you were looking at using some kind of DDL to actually create comments of some kind in there. And I was just, my first thought was that some of that stuff has a lot of global locking in InnoDB and can do some interesting stalls. But I mean, like, it seems like a pretty awesome implementation. And I'm waiting for the caveat, I guess, is the big question, because it seems like, I mean, it's very cool, but it also seems like something we should have known. Like, how did we not do this already?
I can relate to your question, because once I wrote this up, I thought to myself, this could have been written 5 years ago, right? There's nothing new about here. There's no new
right.
There's no new technology here. This is 5 years old technology.
I've done this manually when slaves have failed before.
Right.
Right. This server is critical enough that I have to go comb bin logs and figure it out and get it repaired. That has happened before, you know. But and MHA did try to do some similar. Was it MHA or MMM? One of them did something slightly similar in a very weird way with SSH root passwords and a lot of catting of files out and whatnot. But it just. I'm waiting for the other shoe to drop, I guess. I'm very interested to see whether or not... Do you plan on speaking about this at PerconaConf?
I do indeed. I intend to... I'm writing the proposal right now, so I want to present that also at the FOSDEM in Belgium shortly.
So something I'm wondering is it possible that maybe the reason some of this wasn't known is because the parts of the tool set that's used to achieve this wasn't branded well enough or known well enough? So specifically, Shlomi, I'm assuming that for this all to work through Orchestrator, you're actually using the show bin logs statement in MySQL instead of connecting directly to the server through SSH or something. Is that right?
Correct.
Yeah, and so for example, like I remember Sam Lambert talking about some of this. He was writing a little tool that would do that, and I personally didn't even know that you could issue show bin logs, on the server to get that information. It never occurred to me. I always just went to the file system and would look there. Arguably, maybe if I had read the manual cover to cover a little more engaged, I would have discovered this. But is it possible it's things like that? Maybe most folks, when they're dealing with these kind of issues, don't know that they have some of this stuff available through the MySQL server itself, or something else maybe.
Yeah, absolutely. I also only learned about show bin log events when I read MySQL High Availability by Lars Dahlman and Matt Kindle. So I was also shocked. What? You can get the bin log entries from within the client? Cool. And yeah, it's that kind of thing that you never do manually as a DBA, and so you tend to forget about it. And I can totally relate to John's question. What are the caveats? I don't know yet. We've used it in production at Outbrain, so I don't know. It's definitely better than letting all those slaves die and get corrupted and rebuild them. It's definitely worthwhile trying it out. You definitely need to have smaller bin logs because bin logs can only be scanned sequentially, incrementally from the beginning to the end because they're compressed. You can't just look backwards in the bin log. You have to look forward only. So if you're going to scan a 1 GB bin log, it's going to take some time to move that slave. You need to open a 1 GB bin log here, another one here, and scan to the end to find the GTID entries. I found that 100 megabytes makes for a better performance. So it takes some time.
Perhaps you could use some type of checkpointing, duct tapey checkpointing system with injecting the bin log positions or something into your actual comments in order to give you easier ways to find the offsets of where to look. That might also help.
Right. That might work when you're dealing with binary log files directly on the file system, but if you use show bin log events, then there's nothing you can do. You have to do show bin log events, limit, offsets, and that's all you have.
Okay.
Yeah, I guess you can do a lion in the desert. Yeah, Sean.
Yeah, you say that you need to scan the bin log, but actual true GTID does the same thing. So it looks as good as GTID because this is not a drawback. This is something that already exists in current GTID implementation. When the slave connects to the master needs to scan its bin log. So to me, it doesn't look like a drawback. It comes with GTID, so it's pretty good actually.
So a question that I got on another medium from Chris, I think Chris Shumaki. He was asking about PT Heartbeat. Ultimately inserts kind of this unique information. Could you just run that as your unique identifier potentially?
Yeah. So PT Heartbeat just like writes a timestamp, right? And the only issue with it's pretty good. There's the issue of daylight savings. You might have like at 2 times a year. You might have like an issue with the timestamp not being unique. I'm using UUID, and actually UUID just uses the timestamp plus another random value. So yes, you can use PT Heartbeat to some, for the vast majority of the time, it's gonna do just well. I think so.
I definitely look forward to seeing you talk about this. Have you submitted yet for? What is it? We got 3 more days, right, until the end of.
Yeah. I'm going to submit tomorrow, hopefully.
Cool.
And after that, I'm going to block myself from submitting because I'm also reviewing my papers. So, yeah. I'm just kidding.
Yeah. Which a quick PSA, which I'll say again at the end. If you are submitting a talk to Percona Live 2015, you have until Sunday. You should probably just do it today.
Yes. Please do so. Please do so. And I'm sending free smileys to anyone who submits the paper in time.
So my thoughts, looks really great for our master-slave. Maybe it needs to be extended a little bit for master-master with writes on both sides to maybe filter out same server IDs. Does that seem like, from a high level, a sane way to do master-master with this?
It works out of the box for master-master as well, because if one of the co-master fails and it has slaves, then those slaves are by definition grandchildren of the other master, and you can just promote them using sudo GDID. And you can inject sudo GDIDs on both masters. There's no problem with that. If they're active, there might be a problem. Yeah, absolutely. If they're active.
Yeah.
But if they're active passive, then there's no problem.
That was where I was coming from, was writes on both sides are still
okay.
Out of order. One slips behind, so yeah.
Okay, so if you inject sudo GDID on just one of them, and you can make certain that that is the case, then I think that should be safe.
For slaving from, let's say, an A and a B side, and if you have slaves tailed off of A and B, you have to keep them on their respective sides so that their bin logs stay consistent, which I don't think you could swing from slave on the B side over to the A side without that.
Yeah, good question. I need to think about this. Yeah, it's not trivial.
Yeah, there's some interesting implications there, especially if your transition time from an A and a B side is more than seconds potentially. There's a lot of like when do you transition your unique ID writer and things like that. It almost feels like the nicer answer is you should probably only be running one master if you actually commit to doing this and you trust it to run, which I feel like is kind of the same take with you turn on GTIDs and RBR in 5.6. You kind of at that point you can almost basically use Fabric for everything, and you would probably just trust that everything will reconverge and work the way it's supposed to.
With master, you could probably use server ID to recreate many streams because your pseudo GTID are injected on a master and they have the server ID. So if you have a more complex logic, you could probably use that. It would be tricky, but I think you could.
Yeah, but the problem is that the sequence of pseudo GDIDs injected by both masters might turn up in different sequence on their respective slaves because lags from between those masters might end up with like more sequences from the same master and then a sequence from the other master on one slave, and then on the other side it might be the other way around. So you don't really know.
It's definitely a fun challenge to solve. Anyways, yeah, so Shlomi, I think we're chewing into some of your time. So last chance for questions, I guess, before we let you go. And nothing. Okay, thanks very much for presenting today, Shlomi. This was pretty awesome to hear out and see in action.
Okay. Thank you all, and I apologize, I need to split, so.
We'll see you next time.
See ya.
Cool. Okay, so next up on the topics for today was talking about dealing with logical corruptions. And I think, Jeremy, you had asked about this one sometime during the week. And specifically, corruption can happen at any time, right? And disks go bad and stuff, and that's what we would probably consider physical corruption. But logical corruptions are your application starts accidentally deleting or changing records it's not supposed to as part of a bug that's been introduced. And how do you reconcile that? How do you deal with that? So I think I'll just kind of open it up for you to kind of talk about first, Jeremy, and people can chime in as we go.
Sure. Yeah, the thoughts from our point were, if anybody had started thinking about how you manage any sort of large-scale backfills or data correction, maybe you weren't always tracking your created date, but you have that data somewhere from a log, so you write this long script that runs forever and backfills a bunch of data, but you accidentally put it in modified time instead of create time. So now you're either restoring from your backup and having to redo your entire thing, or you write a different script that goes in and tries to correct that. One of the things that we've been talking about here was entity-level backup, and so you would take, for our purposes, a user or a shop, and you would back up all of the information for that particular user or shop. in its own separate, well, really from an entity. You might call foreign keys, which we don't use the foreign key aspect, but we have the ORM relationship. So really I was curious if anybody else had any practical experience or discussions internally around how you might recover from maybe one user's data has gotten messed up, but you don't realize it for a significant amount of time. Maybe your backups are gone from that point. Or how do you deal with maybe database versioning? There was a database engine concept for versioning that kept sort of it would basically write a different row, I think, or the change sets from each row, and then roll everything up into your view, and then you could scale backwards. I can't remember the exact name of it, but I'll find it real quick for the chat. I think it was like DD Engine or DD Change Engine or something similar to that. I'm curious anybody else's thoughts on that one.
Maybe, and looks like Sam just joined. There he is. I don't know if his mic's working yet, but just some background for you, Sam. We just started talking about logical corruption and how to deal with backups with that. And Jeremy was just mentioning, I'm curious if anyone's done entity level type backups where you grab maybe a user object and the relationships and the rest of the data store to that user and back up that information specifically. I remember that, Sam, you had talked about being able to just back up tables, I think, using Qbot. And I'm just curious how that looks for you.
So we have a couple of different backup systems. We have, automated extra backups which take the full snapshot of backup hosts for each cluster. We also have a different system which is like a parallelized job queue, which can handle various different types of backup job. So one of those jobs is actually uploading extra backups offsite and taking them out of the data center. Another job is taking a table and backing that up and uploading it to external storage. And that can be triggered in various different ways. So like that's triggered every 4 hours via cron, which basically just grabs a list of the tables and pushes them out into individual jobs. And then that's like spread across. You do the dump from various different hosts and it's uploaded. You can also trigger that using Qbot, our chat bot. So you can say to him, back up this table, and he will create a job, and then that will be backed up, and then it posts back to the chat room to notify that user that the table's being backed up. And you can also then view all the different snapshots of each table. So we've had issues in the past where users have, created API agents that have deleted like various different parts of their organization, so labels, things like that. And we've been able to use, the developers or the support developers have been able to look at like a list of when all the different backups have happened. You give it an ID of that backup, and it will populate it onto a staging environment, and then you can use the like Rails console to basically pick the different attributes you want, and then populate them back into the main database for like restoration. So that's really how we do backups.
Yeah, that's interesting because for us we have a backup, architecture put together that's responsible for running extra backup on a regular basis, and we also have, so those are dumped every day. There's a full backup. We always have binary log streaming in, so we don't do entity level by any stretch of the imagination right now. But things happen where there's some sharp edges in our application. I think one of my favorites was one of our customer support tools for removing a user or some other object in the system could delete some other information that's used by other users in the system. And so when that happens, my team will get a ticket saying, hey, can we recover this data? And thankfully we have a couple weeks, couple months of data available in a backup, so we can just spin up one of those old backups on the spot on our backup servers, run a statement to get all those records, and then reinsert them into the active topology to put the records back. But I think it'd be actually very interesting, just the notion of being able to back up entity level stuff. It's something that we've been talking about specifically for debugging customer issues that we can't reproduce in our dev environment. And so currently we have a set of replicas in our environment that are specific for engineers to access this customer information after they've been granted access, just so they can see this issue that's not reproducible, and then potentially write scripts and stuff to kind of munge with the data on this replica only, where they can test it out. Because of that, we need to have a whole set of replicas of everything in our upstream topologies available, which is a little expensive. So it'd be nice if we could just kind of take a snapshot of an entity and import that into a local data store that all of this stuff could use, and then that way we don't have to like periodically refresh these replicas that are specifically for engineers to reproduce customer issues with.
Yeah, the simple method seems like rather than ever doing an update, you always do inserts, and you just keep some sort of modified timestamp, and then you have this history with maybe a purging process that keeps your last n number of changes, and your ORM automatically knows. That seems like a way to kind of make all that data online, but it's hugely wasteful on like disk space. So if you just spiraling out of control for changes, you're going to have a really bad time on disks. So that's why I was curious if anybody. I think with the right foreign key structure, you could probably walk through automatically and build some entity level stuff. If you have good ORM instruction, you could probably do the same. Mostly looking for feedback on ways to accomplish this. Our biggest concern, I think, is something gets changed on a user and you don't realize it until after you've passed your last backup. And most people, don't keep backups forever. You generally keep some sort of retention of, a week or 2 weeks. Or something, even do incrementals, but still, you're at some point that data is going to drop off and you can't revert back to what it was. And we're looking for a more tightly compressed way to store individual values that maybe says we're going to keep the last 10 changes for every user or every shop. We know that there's a limitation there, but if that user's data hasn't changed in a while, we still can get back to what we're looking for.
Yeah, I'm actually curious to hear from some other folks about this. Jean-Francois, Pim, just how do you deal with logical corruption and what kind of methods do you take to it?
Well, it's not something I have a lot of experience with, but it's a wild idea. We're experimenting with replicating to Hadoop and to Hive. So the idea is first you have your state in MySQL, and if you have a copy of that state in Hive, it's the same. So that replication to Hive, the way it works is, well, every insert is an insert in Hive, so it's easy. Every update is a delete followed by an insert, and every delete is a delete. So you have a state of your data, and then you have a series of mutation of insert and delete to that data. And once you have that, you're able to rematerialize your data, well, your view of your data at any point in time. So this could be a way to go back to review of the data in the past if you set this up. And we're experimenting with that. It could be a way to achieve to do what you're trying to achieve. If somebody would like to work on that, I guess it would be a way to do it. Does it make sense?
Yeah, it does. I was just waiting to see if someone else was going to chime in with their experience. But okay, if someone's looking for this challenge, Jean-Francois is looking for you.
I know. Sorry, go ahead.
Well, I think this could work. There's some people that are working on that at booking and out of booking at that time, so we could poke those people.
Okay. Sam, were you going to say something?
Slightly related to logical stuff. I know we have an ability to clone our own user, for example, down from development, and that's through Rails, and probably related to active record RMs. You can grab all the associations and basically pick that user object, for example, or repository or organization. So it's not related to any backups, but that's got me thinking. I wonder if we could actually do something, similar to that. Maybe serialize all that data and store it somewhere. There's some potential for using an ORM that could be able to do that.
So here's another interesting thought. How much do you duplicate some of the data that goes into your data store? And so specifically, I remember we had a logical corruption issue at one point where a bunch of data was just kind of disappeared, and thankfully we were able to piece together all of it by going to various other methods of things that we log. So, things that went to our analytics pipeline for business analytics, we had all that information available in HDFS that we were able to reinsert back into everything to get everything back to a consistent state. And just kind of curious, how does that look for other folks? Do you have other, because a logical corruption is going to corrupt everything in your replication topology, potentially, unless you have a lagging slave, maybe. So what kind of, how do you ready for that? What do you do in those kind of events?
Lagging slave saves you if you catch it in time. If you've had some sort of issue that happened past that, and I don't know how many people keep multiple lagging slaves of all their data sets at different time intervals to try to catch it at the right point. But yeah, that's the one I'm actually trying to look at. We do a lagging slave actually in our infrastructure today, and so as well as like offsite copies and things like that. But for our purposes, we're more interested in an individual entity's version of changes over the entire history of their entire change. Infinite disk space, that's not too terrible, but how do you present that in a way that your application can access it, store it efficiently, and with the Valhalla of as little implementation time as possible.
What about some other folks? I'm actually curious. We used to do lagging replicas, but with our new backup infrastructure, since we're taking them so regularly on an automated fashion, we actually did away with our lagging slaves. No one else does anything fun with backups?
Not really. We have lagging slaves and a panic button that developers can hit, which disconnects that, and then pages me. But other than that, we don't really have anything apart from logical and full backups.
Okay. John, how about you? You've been very quiet.
Yeah, I think this is such a company-specific type of thing that besides delayed slaves, it's very difficult to say and give a lot of advice without saying that. I think something I think it was you touched on actually was a lot of the more modern architectures have very tiered approaches to the data storage in general. In that even if somehow your MySQL layer was nuked or Godzilla'd tomorrow, you would just go to the archival tier, and sure, the business would suffer in the meantime, but there's so many copies of the data in so many various levels that it's very difficult to actually get a permeated logic corruption. And then Jeremy touched on the second problem with that is that, or more of a distinct problem with that is that even with delayed slaves or even with multiple layers, I think the real question is how do you detect logical corruption and what is logical corruption? And the problem with that is so application specific. It's very difficult to detect, and really what it comes down to is do your testing and staging, and make sure data integrity is just as important to your application as it is to your database. So I unfortunately don't have a lot to say about that other than it's a difficult problem, and I don't know if someone said that was a enormous priority for me to forever be protected from, it would probably involve such strict developments that the company would grind to a halt, because every time they did any minor release whatsoever, there would have to be a significant amount of both retroactive and forward-looking testing on the data tested and generated and everything else, right? And again, defense in depth means you got to be cost-effective. So having 10 slaves, each one delayed a separate hour, is not cost-effective to most companies, and neither is making sure that every single time you introduce any sort of code change that could possibly manipulate data in a different way, that you go through and make sure that in all edge cases and all outliers it's perfect. So I think what we already do with backups is really the best way to solve this. Is just to make sure you take as many backups as possible, make sure you know what to do in the event of a DR situation, and make sure you test your backups. And everything beyond that is going to be very company specific and constrained more by budget and velocity of the company than anything else.
It's interesting, John, the way that you change the conversation is it becomes a data quality issue.
Right.
And another example, not quite like this, would be if you were to deprecate a field. Do you drop that from your database? Those sorts of inconsistencies. Everyone aims at 100% for data quality, but nobody really quite gets there. And so
Right.
we all have different tolerances to that based on our organizational needs. It's true. I agree.
Exactly, right? Like, it really comes down to, like, how much money do you want to throw at the problem to make sure it never happens, and to what extent do you want to make sure it never happens? And it's all tangentially related to absolutely everything we do in tech. Is how much money are we willing to spend to make this cost-effective company? At the end of the day, it's always fun to work with data, but our job is to provide value to our company in a cost-effective fashion. I hope someday we can all just nerd out in a room and never have to worry about paying bills or anything like that. But it's kind of an unrealistic goal.
That's actually coming up in April, John. There's this thing called where we put a bunch of nerds into a big building together and we tell them to nerd out.
And hopefully some good things come out of it, right?
I promise it's coming.
I do have one other comment. When you started the conversation as well, Jeff, it was interesting. You talked about physical, and you said this is different from physical, this is logical. And I thought I'd plug that InnoDB has page checksums, so that physical can't spill into logical. So from the database's perspective, it's aware of this problem as well and has some of its own defense mechanisms.
Yeah, and the reason I specifically broke those apart was I can't remember offhand who did this presentation at MySQL Connect 2 years ago. I was one of the fellows that worked on a lot of the RDS stuff at Amazon and putting together the MySQL and Oracle setups for it. And he had a lot of information to talk about around corruption just in general. And he would go in and munge data files just to prove points. And it was really cool. It was extremely informational. But one of the things he was pointing out was, logical corruptions. These are the things that application people do. They manipulate the data in a way that they probably shouldn't have. It violates your business constraints, and it makes things a little upset. And then physical was specifically that problem of the data file is messed up. Something changed in it. A bit got flipped where it shouldn't have been, or maybe you had a disk failure inside of a RAID, and it actually happened to do the magical corruption that you weren't expecting. File system errors that happen on the machine, anything like that could cause these kind of problems. That's why it's very interesting. We always talk about a lot of folks take extra backups, and so you have that hot backup that's ready to go. If a server crashes, you can just throw it on there and spin it up, and you're good to go. But then the more kind of involved part of that is how does it look when you have maybe you've actually been cloning what I would consider physical corruption, a bad IB data file every time. And it's only been getting worse because you keep copying that as your extra backup. And that's one of those situations where, wish I had a MySQL dump now so that we could do a fresh setup of everything without all that. I mean, it'll take forever, but you'll have a stronger confidence that it's there. And it's especially true when you're going, you're doing an upgrade between major versions. There's an upgrade path. Everything should be good. You run the MySQL upgrade command. But, you might feel a little bit better just having that logical dump that MySQL dump file just in case, I'd love to hear other people's thoughts on it, but yeah.
If 8 happens to change its definition, mid-upgrades or something like that happens. Like maybe a German S definition changed in a minor revision in a minor note at the bottom of a changelog.
I hate you, John.
Suddenly everything's exploding in production. So.
This hasn't happened to you, I guess.
No, never.
Of course, once you've got your physical corruption, most times you can't take a MySQL dump anyway.
But the act of taking the logical dump would most likely trip you up to its existence.
The act of backing up should too. Both extra backup and MySQL Enterprise backup will verify the page checksums as they copy.
Right. So that's it's more like, when was the last time you did a backup restore?
Right. So,
everybody should be asking that.
This is an interesting reason why not to use snapshots, actually, and why to use one of those two backup tools instead, because you'll verify the consistency, at least to a large degree, as you're copying it.
That's actually a good point. I forgot that. So are using LVM snapshots, I assume, right? Or some sort of file system snapshotting? Oh, maybe not.
We
Okay.
don't know for certain.
But yeah, that is a good point, Morgan. Using a tool like Extra Backup will and MySQL Enterprise Backup will do that extra validation on the data files after it's done it. But if you're just doing a file system snapshot, like it's great because it's super fast. But if there's some other thing floating around, you won't know about it until later.
In both cases, as they're doing it, as it's doing the copy, it verifies the pages.
Cool. And so to your point, Pim, about if you try to do a logical dump and that's when you actually find out about it, yeah. And I mean, I remember the last time, luckily it was a small server I had to do this on. It was one that supported our Puppet infrastructure of all things. And so, it was maybe a 400 gig data set. It was not too bad. But, the server kept crashing when it tried to touch a certain record. And that was the first time I had the pleasure of learning how to get a logical dump of a corrupted data set. And you effectively have to select a data from a table up to the point where there's a corrupt record, and then select after that record and just say, okay, that record's screwed, and you're going to have to piece it together on your own with opening up the emergency or like the special toolkits to read through the data files and stuff.
Yeah, I just had the pleasure of doing that 2 days ago, so it's fresh in my mind as well.
Do you want to talk about it, actually? Because that's not something people hear about a lot.
A server crashed, or actually it was an Amazon instance that was impaired, and after we brought it back, it was terminated mid-write. We couldn't bring up the MySQL, or MySQL just wouldn't come up anymore. Crashed immediately when it started. So the only way we got access to those data files was by using a trick from the performance blog, by copying the IBD files, creating new database based on the same schema, and then creating fake tables with the same table space ID, discarding the table space, attaching the table space, and then doing a MySQL dump per table. And as you said, you get to the point where you find out this record is where it gets corrupt, and you get as close as you can to the max number of records you can export that way, but it's hard to be sure.
Did you have to do any of the, I can't remember the flag offhand, but there's the config option for the amount of safety checks InnoDB will do to recover data when it gets corrupt, and you keep increasing that number?
Force recovery mode, right?
Yeah, that's the one. Those. They didn't help get past the recovery, or didn't help in getting MySQL up and running.
Dang, that's bad.
Yeah, I called in Percona as well, and they said that they couldn't help with that either. So.
Yeah, everything below 3 is just disabling all the safety checks at startup, and everything after 3 is completely ignoring any sort of data integrity whatsoever.
True. Percona has an interesting option where they can actually skip past a corrupt table, just give you a warning.
Right. That's the what is that? It's going to be corrupt table action, right? You can change it from ignore whatever it is. Again, though, this is why everyone should be testing the restores of their backups, because I can't think of how many times I've actually gone to use force recovery and then come away from it going, wow, I really feel like I succeeded there, and I totally didn't absorb way too much of my time. It's always more cost-effective to just have a robust backup solution. In this day and age, storage is in no way cheap, but bulk storage is close to cheap and usually cheaper than hundreds of man-hours of opportunity cost and labor cost, right?
So if we've learned anything today, it's if anyone who's watching, if you have a data corruption issue that InnoDB force recovery can't get you past, call Pim. He's done this. He knows what's up.
I'm not sure if I'm too happy with that recommendation.
And then the Percona actually has some cool tools buried in a repo somewhere for actually manipulating corrupted data and trying to pull it out, and deleted data as well. I think once I decided I needed to test those tools, I also decided that maybe a different course of action was necessary to recover from that incident. It was a long time ago, too.
So I actually just, someone had sent me some of the information about the force recovery options. Yeah, and it's on a scale of 1 to 6. The first one is serve force ignore corrupt, which keep the server running if the page is corrupt. uses to dump tables. The second one skips purge operations in case the purge is breaking things. The third one skips transaction rollbacks after recovery. The fourth skips insert buffer merges. Fifth does not look at undo logs, so incomplete transactions are treated as committed. And the last one, number 6, do not do the log roll forward in connection with recovery. So yeah, you are literally throwing out complete aspects of integrity once you get above 3. It's kind of scary. And actually, Tim, I want to ask you, with TokuDB, what's this stuff look like? You know, do you have some crazy recovery options if something goes wrong there?
No, not much different than what's been described. You know, we've had a couple times with users having to do they ended up with corruption due to hardware misconfiguration, and then they play the game of bring the system up, try to find where in the PK range that the corruption exists, and then do an export for less than that range, and then greater than that range. We do have one interesting advantage, though. We support clustered secondary indexes. So if the user happens to have a secondary index clustered, it's kind of like RAID for your data, because it means every row, in its entirety exists in 2 different indexes. So we had a user once that had a corruption on the PK index, and they were able to export all the data out of the secondary index.
That's actually very interesting. And I mean, in doing this process, though, is there any sort of similar to the InnoDB forced recovery option where you can tell it to disable more and more safety checks to get at it, or is there something else that is done specifically to get the server up and running in those situations?
No.
Okay.
No, I mean, the worst recovery we've had to do was what I'm sure the InnoDB people have done occasionally, or Percona has hacked on it, where we have a tool that ships with our software that can read a fractal tree directly, and then that's old school, because the data is not coming out row data, it's coming out encoded in the MySQL row formats, and you're kind of putting it all back together on your own.
Sounds exciting, actually. Cool. All right, well, we've got about 3 minutes left, so any last thoughts or comments on, I mean, it kind of opened and ballooned into just a conversation around corruption at this point.
Just out of curiosity, does anybody know of any tool to actually manipulate the internal data dictionary?
Yes. Jeremy Cole's Ruby stuff, I'm pretty sure you can feed that in the IB data file and kind of poke at it. I don't know if it allows you to manipulate offhand, but it wouldn't be hard to let you do that.
We also have a labs release of the new data dictionary, and when it is made official, you probably won't be able to manipulate it, but in the labs release you can manipulate it, and it's probably still discouraged in the labs release, but it actually shows up like regular tables in the MySQL schema.
So that's good to know, and that's coming. That there's going to be it's doing away with FRM files, right, Morgan?
That's correct. Yes.
Okay.
That's correct.
Okay. All right. Well, I guess let's go ahead and solicit for some topics from folks. So we didn't get to mixing metadata this week. We can talk about that next time. Is there anything else folks want to talk about?
I do. How many people here use InnoDB compression in production? Anybody?
Okay. InnoDB compression for next time. Cool. What else we got?
No, I wanted to talk not just about using it. I want to talk specifically about how everyone performance tuned it on 5.6, and any metrics you guys saw go out of whack with it, and general differences between your vanilla performance and your compression performance.
Okay. Cool. Got it.
Maybe interesting to have someone talk about punch hole at the same time with the new compression. Because the new compression should technically be superior to the old compression. It pushes a lot down to the operating system, and it'll probably compress at higher rates in most cases.
Okay, cool.
And then maybe we could get, we could talk about Toku, kind of has very good compression as well. And then, I'd love to see, maybe we could get a cook-off between all three going on. I don't know if people are organizing in the meantime.
I think Tokyo will win a lot of cases. It's got the 4 megabyte page size.
Yeah.
Okay.
Anyway.
Any other?
Thank you very much.
Yep. Take care, Morgan. Any other topic ideas before we wrap up? Jean-Francois, Pim, anything you guys would want to talk about next time? Just shaking your heads.
Everybody, we're all going to talk about compression.
Okay, compression will probably take up a good chunk then.
Yes.
All right, cool. Alrighty, then that's it for this week. So we're actually not going to have DB Hangouts in 2 weeks because that's Thanksgiving in the United States. So we'll see everyone in 4 weeks.
All right, sounds good, guys.
All right. Thanks very much for your time today, guys. Take care.
Bye.
Bye.